Thunderstorms look beautiful and terrifying at the same time, but inside them is a powerful engine of heat, motion, and electricity. Every thunderstorm starts with warm, moist air rising rapidly from the ground. As the air rises, it cools and the moisture it carries condenses into clouds. This condensation releases heat, which makes the air rise even faster. These rising columns of warm air are called updrafts, the heart of a thunderstorm. Higher in the cloud, temperatures drop below freezing. Droplets turn into ice crystals and tiny hailstones. Updrafts lift these particles upward, then gravity pulls them back down. This constant collision of ice pieces builds electrical charge, like rubbing materials together. Lighter, positively charged ice rises to the top of the cloud. Heavier, negatively charged particles fall to the bottom. This separates the cloud into an enormous electrical battery. When the charge difference becomes too large, electricity jumps through the air that's lightning. Lightning superheats the air to about 30,000 degrees Celsius, hotter than the surface of the sun. That heat expands the air explosively, creating the shockwave we hear as thunder. Meanwhile, rain forms when ice particles partially melt as they fall. In strong storms, updrafts can lift hailstones back up over and over, adding more layers of ice. When the storm can't lift them anymore, gravity wins and hail falls. Thunderstorms also create strong wind. Downdrafts form when cold air plunges toward the ground. When these downdrafts hit the surface, they spread outward as powerful gusts. Some storms rotate, forming supercells, the type that can produce tornadoes. Rotation begins when wind speeds change with height, causing the air to spin horizontally. Updrafts tilt that spinning air upward, creating a rotating column inside the storm. Most storms never produce tornadoes, but every storm shows the same powerful forces shaping our atmosphere. More daily weather breakdowns coming your way. Stick around for tomorrow's explainer.